This is our vision statement. Thinking about math not as a collection of isolated concepts, but ever-evolving body of interconnected knowledge. This is super important for us in the math department. There's certainly integration we're doing with other subjects as well, but I'm going to focus most about the way we integrate our curriculum within the math, because that does make us different than a lot of schools, the way we kind of think about math as a subject. I'm going to go through kind of our core principles. First is we are innovator-centered. If you were to walk into my classroom, Cassandra's classroom, Anna's classroom, what you're not going to see is one of us standing at the board giving a 70-minute lecture. You might see us a little bit presenting material, right, because they're not going to discover math on their own, but mostly what you're going to see is kids working together, struggling through problems, discovering things, and us running around the room trying to answer all their questions, helping them to really get their hands dirty and discuss and debate and wrestle with these concepts. Second is that we're looking at the interconnectedness, and then this idea of spiraling, because all too often in schools, the way the math curriculum goes is, well, you do Algebra 1, probably in 8th grade, and then you do a year of geometry, and then you do Algebra 2. Just enough time for you to forget all of your algebra. So in Algebra 2, you spend the first half of the year reviewing Algebra 1, and then the geometry doesn't get touched really ever again until maybe you get to some calculus problem where there's a little bit of geometry in it, and then they're like, oh God, I took that in 9th grade, I don't remember any of that. Instead of doing that, what we're doing is we're spiraling it. Every year they're getting a little bit of geometry, a little bit of algebra, then a little bit of trigonometry stuff as they get sort of more advanced, a little bit of statistics. Most of you, if you use any math at all in your day-to-day, you're probably doing statistics. You might have to look at some data. So that's really important that we've woven that into the curriculum. And then the last point is that we progress through the math sequence by stage, not age. Kids come in and they are placed in the content area that they are ready for. You may be in different phases depending on sort of where you come into NEIA and how you're progressing through our curriculum. So, math, scope, and sequence. What I want to point out to you is things like geometry pieces, area and surface area. Here, this is grade 6, kind of our entry point, and then we get angle relationships, kind of here in the next year, Pythagorean theorem, translations of things, similarity, right? And then we kind of get into higher level things where we're using trig functions. They're building it as they go. And you also see the same thing with sort of statistics kind of woven throughout. And you sort of layer it a little bit each year, and every year the level of abstraction gets a little bit harder. That's kind of our ethos and why we've sort of swirled it the way we do. And I spend much less time having to review things because we keep spiraling back to it along the way.